So, hello everyone. My name is Subham Kumar Agrawal and welcome back to my YouTube channel, that is DU Chemistry. So today we are going to start the nuclear partition function because we have done the vibrational and electronic in the last video lecture. So today we will complete the nuclear partition function, and along with we will do some questions as well. And I think I had said that I will also cover some questions of electronic partition function as well, because in the previous video of the electronic partition function I had not covered as much questions as it is required. So I will do 1 or 2 questions of electronic partition function as well, so that you will get much idea about how you have to approach the questions. Alright, now let's begin. So in the nuclear partition function you have to just apply the concepts of NMR spectroscopy. What you have read in the NMR spectroscopy, that due to the spinning of the nuclei, there occurs a splitting when you applied the external magnetic field. Then you will get a splitting in the energy levels. So that splitting of the energy levels is our system in this case will be our system, that splitting of the energy between the two levels, and those two energy levels, so those two energy levels which we get upon splitting when we applied the external magnetic field will be now our system. So that is we call one lower state as a alpha, and the upper state, which is the excited state, which has a higher energy, will call it beta state. Alright, so this will be our system, and only this system we will going to deal it. So these two systems are like here. Alright, now I think that's all for the concepts, and upon going with this question you will get an idea that how you have to approach this question, such type of questions. You will get a deep understanding about that as well. So let's do this. First of all, read the question twice. So that you will not do any kind of mistake. Alright, so what the question is saying: if the energies of bare protons aligned along and against static magnetic field are the energies of the two states are given to us. The energies of the two states are given to us. For the alpha, the negative energy will be of lower state, that is alpha, because it is actually the stabilization energy, and the higher energy is of beta state. Alright, okay, now so the energy of the two states is given to us, and what is asking that the ratio of the probability of finding the proton along and against the magnetic field. It is actually saying the two states which we will get, the ratio of finding the protons, means we have to find out the probability of the protons, and it would be n1 upon n0. It is actually we have to find out this thing, n1 upon n0. Alright, and the 4 options are given to us. Alright, so yeah, 4 options are given to us, and now here these are two energy levels, and we designated their probabilities as P0 and P1, and the energies, as you can see, gamma h cut bz upon 2, and the same with opposite sign of the excited state. Alright, and according to the question we have to determine the P0 upon P1. Try to read the question. It is asking, wait a moment, yeah, So the question is asking to us the probability of the proton along and against the magnetic field. So the energy state which is along the magnetic field is the alpha state, that is the lower state which will be the along the magnetic field, and the energy state which would be against the magnetic field would be the beta state, or say beta energy state. So what is the question is saying, like find the probability of finding the proton along and against. So along, P alpha upon against, that is P beta. We have to actually determine the P alpha by P beta. If we say alpha energy E naught and beta energy E1, then actually we have to find out P naught upon P1. Is this thing clear to you or not? Is this thing clear to you or not? I hope that you people might be clear with this. Okay, now moving to the solution part. As we know that the degeneracy in the nuclear energies are 1. The degeneracy means when the nuclei will get aligned and against of the magnetic field, then they will have only single degeneracy. They will have the single degeneracy. So G0 and G1 value will be 1. Now we have to actually find out the P0 upon P1. We have to actually find out the P0 and P1. Alright, and we know the formula. We know the formula for P0. P0 equals to e raised to the power minus beta EI, so E0 upon partition function for that system, for that energy state, and divided by, so when divided by factor will come into multiply, it becomes opposite. So what is written to here is the same for the excited state, and whose energy is even, as I had already said. Alright, okay. Now the partition function would be same for both of the state, and it will cancel out, and will denominator will take into that numerator, then it will get this one. And here one thing we can conclude, that the probability depends only upon the energy difference. Probability depends upon only the energy difference. Alright, so just we have to put these values because these values are given to us. So upon substituting all these values, we will reach to our solution. We will reach to our answer, and the answer is P0 upon P1 equals to e raised to the power h cut gamma bz upon kbt. So option number D is correct. Here it would be h cut, and option number D would be correct. Alright, now as I had already said that I will cover some of the questions of the electronic partition function as well. So here is the question. What the question is saying, as already what I said, as usual what I say, that read the question twice, so that you will not going to make any kind of mistake. Alright, so the question is saying NO molecule has a ground state. What is given to us? Term symbol of the ground state. NO molecule has a ground state, and the term symbol of the ground state is given to us, and excited state to symbol is given to us. Alright, and we know that how to calculate degeneracy from the term symbol. We know how to calculate degeneracy from term symbols. So writing down the energy states, and along with we will write the degeneracy at there only. Alright, so that we will not mistake further. Alright, now what is saying, the energy difference is 1 to 1. Now energy difference between the two energy levels is 1 to 1. Alright, so in one more thing that I want to tell you, in the electronic partition function, try to write it down as a note, like in electronic partition function, until and unless the question will not say that the ground state energy is not zero. Try to listen my words. Until and unless the question will not say to you that the ground state energy is not zero, you have to assume the energy of the ground state as zero. You have to assume the energy of the ground state as zero. Try to write it down as a note, because it will help a lot. Otherwise you will forget in 1, 2 or 4 days. Alright, now as what I said, we have to take the energy of the ground state as zero until and unless only when the question has not said that it is not zero, that it has some value. Alright, so we have to look at least once at there. Alright, so the energy difference is given to us 1 to 1 centimeter inverse. So if ground state energy is 0, the excited state energy will automatically be 1 to 1 centimeter inverse, because this is actually the energy difference. And if ground state energy is 0, and the energy difference between the ground and excited state is 1 to 1 per centimeter inverse, then automatically we can say that this is actually the energy of the excited state. This is actually the energy of the excited state. Alright, now we have given us the levels. We have given us the levels of the ground and excited state. So what we are going to do? Wait. Yeah. So what we are going to do? We are going to write it down at the next of the energy levels, their term symbols. So what is the term symbols of the excited state? It is the 2 pi 3 by 2, and for ground state it is 2 pi 1 by 2. So it is the molecular term symbols. Alright, are you getting this? That sigma, pi and phi, all these symbols were, I had told that we will use these when we will deal with the molecules. Alright, otherwise in case of the atoms we use S, P, D, F and so on. Alright, so here we can conclude that NO, it is for the NO molecule. Definitely we can conclude that it is for the NO molecule. Alright, now try to understand for the molecule, it is the symbol in the form of levels. It is in the form of levels, and in the levels what I had told to you that if the lambda value, if the lambda value is non-zero, then for the levels the degeneracy becomes 2. Alright, so here we can say for the pi the lambda value is 1. For the pi system lambda value is 1. It means it is non-zero. So degeneracy will becomes 2. So for both of the ground state and the excited state, the degeneracy is 1. Degeneracy are 1. Alright, is this thing clear to you or not? We have to actually find out the partition function, and at 3 different temperatures. Alright, now what would be the formula? For the partition function? Very generalized formula we know that Q equals to, for 2-level system. For the 2-level system, it is this formula. Alright, now on substituting all the values, we get this. G0 and G1 has value 2, and E0 is 0, and E1 is the 121 centimeter inverse, and we get this expression. Of partition function. Alright, now we have to just put the temperature. Values, and we will get all our desired answers. So first of all, on substituting temperature equals to 0, what we will get? what we will get, we have to just put the temperature as 0, so we will get exponential minus 121 upon infinity, that is upon 0, so whole exponential becomes minus infinity, and minus infinity is 0. E raised to the power minus infinity has value 0, it has value 0, so we will get the partition function as 2 for the system having 0 temperature. And it is very obvious, and it has already, I had told you that at temperature 0 only ground states can be accessible, so there are two since degeneracy of the ground state is 2, so only 2 states can be accessible. So this is for very conceptual way what I had told you. Alright, now moving to the second part. At temperature 298 degree Kelvin, we have to just put the temperature and K value in form of centimeter inverse per Kelvin, so that centimeter inverse will cancel out, and per Kelvin and Kelvin will cancel out, and you will get your desired answer. Alright, so at temperature 298 you get the Q value of 3.12. Is this thing clear to or not? Say in form of yes or no. Say in form of yes or no. Now the third thing that is remaining is at the temperature infinite. What will happen at temperature infinite? I want from you people that you will answer. You answer for yourself that you had studied the statistical thermodynamics, because I had done it many times, that at temperature infinite what will happen. You know very well at temperature infinite all the states will be accessible, as I had already told you. So in this case there are 4 states, 2 in the ground state, because the degeneracy of the ground state is 2, and for the excited state degeneracy is 2, so there are 4 states. There are 2 levels, but there are 4 states. Try to understand. The levels we designate in terms of the energy, or the level having higher energy will be considered only one level, but in that particular level there may be many states. So in the ground state there are, as it has 2 degeneracy 2, so for the ground state and for the excited state there by total there will be 4 energy states, and at temperature infinite all the energy states will be accessible. So we here are saying that all states will be accessible, so partition function will be 4. Is this thing clear to or not? Alright, and one more thing, that Q without 0 point of energy, partition function without 0 point of energy will tell you the number of accessible states. If you people not forget it, then you can easily understood this thing, that QWOZPE will tell you the number of accessible states, and at temperature infinite, since all the states can be accessible and there are 4 states, so we here saying that Q equals to 4. Q will be equals to 4. Alright, now the last question for the electronic partition function from the account of electronic partition function. Here again I am requesting you to read the question twice. So what the question is saying, that a certain atom has a 4-fold degenerate ground state. What is saying? A certain atom has a 4-fold degenerate ground state. Degenerate means same energy levels, and 4-fold means there are 4 energy levels which are of same energy. There are 4 such levels, and it is asking for the ground state. It is asking for the ground state. So what here I can say, that the degeneracy of the ground state is 4. the degeneracy of the ground state is 4. Now moving ahead to the question, and a 6-fold degenerate excited state, and a 6-fold degenerate excited state at 400 centimeter inverse. Excited state, it is saying for the excited state, and the degeneracy is 6-fold degenerate. Try to understand the meaning of these two words. 6-fold degenerate means states of same energy. 6-fold means 6 are such energy levels. Number of such energy levels are 6. So excited state energy levels are 6, which has energy 400 centimeter inverse. And what I had already told you in the previous question, that unless and until in the question it has not mentioned that the ground state energy is 0, is not 0, you have to take it the energy of the ground state as 0. Alright, so here I had assumed the energy of the ground state as 0, and since the energy of the first excited state is 400 centimeter inverse, and this degeneracy, as I had already told, that for the ground state it is 4, and for the excited state it is 6. Alright, now what is being asked in the question, calculate its partition function at 25 degrees centigrade. Calculate its partition function. We have to calculate the partition function. So we know the generalized formula for the partition function. Is Q equals to this for the two-state system. Now putting the values of Z0, Z1, E0 and E1, and doing some simple mathematics, we will reach out to our solution part, that is Q equals to 4.86. So this is actually what is being asked in the question. Alright, so I think that's all for today. And we had completed the nuclear, electronic and all the partition functions in a very wonderful manner. And from the next video onwards, I will be starting the molecular average energy. Alright, so with a very warm welcome, I welcome here from right now to the next video lecture, and we'll do a great job again in the next video lecture. So till then, see you, have a good day, bye bye.